Hi there, and welcome to our webinar, Tips for Making Your Website Load Faster. I'm Justin Thorpe, Marketing Manager for AddThis. Before we begin, just a few housekeeping notes. We're recording this webinar and we'll send out the links to the recording and slides. Please submit your questions via the Zoom console on the top of your screen. For those of you not familiar with AddThis, we help you attract and engage your web and mobile visitors with smart and beautiful marketing tools powered by extraordinary interest behavioral data. With AddThis, we place a premium on performance. Instead of loading a lot of different tools with AddThis, you get sharing, follow, content recommendation, and targeting tools all with one piece of JavaScript. We're constantly optimizing our code so that it loads as quickly as possible. This includes adding new data centers all around the world. And we try and load everything asynchronously. Get these tools and many more free at addthis.com. On to today's talk. A little bit about our speaker. Andrew is the senior developer at leading creative agency ISO. Their creative leadership has landed them clients like Facebook, NBC Universal, Kroger, and many more. He is also the front-end development instructor at Lead Coding School General Assembly in Washington, D.C. For today's talk, Andrew will talk about the importance of making sure your website loads quickly and the benefits that has. He'll cover common mistakes, tools, and tips to make your website load more quickly. And now, Andrew, over to you.
Thanks, Justin. I appreciate the introduction. Now let's get started with some tips for improving website performance and load times. So first, a little bit about me. Like Justin just mentioned, I'm Andrew Krachik, and I work at ISO. I'm a senior web developer and way more of a nerd than it should admit when it comes to performance. If you'd like to reach out to me, I'm at Krachik on Twitter, but if that's too many consonants for you, you can also reach me by email to andrew@isl.co. And just a side note, I love cold brew coffee, so if you mention you'll get me some, I'll be extra sure to respond quickly. So first, let's go over the agenda for the webinar. We're going to look at an overview of what website performance is, what load time and page weight mean, and most importantly, why it matters for your users. Then we'll cover some common areas in website development that are key for reducing load time: images, third-party resources, caching, and content delivery networks. These are the easiest parts of a website to change that can result in dramatic decreases in load time and page weight. Finally, we'll cover approaches to consider if all else fails. We'll discover how to hide a long wait without making the user really feel like they're waiting on something. So to get started, let's take an overview of what I mean when I say website performance. Because in the physical world, it's easy to measure performance with things like size, time, and distance. For example, a larger object will take more time to transfer further distances. And similar rules also apply to the internet. The bigger a resource is, the more your browser needs to download, which increases the time it takes to load a website. So simply put, website performance is how quickly a website responds to web requests. Size matters, distance matters, time matters. All of these factors and more compound and can result in a long wait time and slow loads. Our job in making websites is to minimize the amount of time to fulfill a user's desire to retrieve content. You want to keep a user's attention, and unfortunately their attention spans are shorter than ever these days. And the reality is that nobody likes to wait. A user chose to come to your website out of the millions of websites out there. If they have an unpleasant experience on yours, they'll remember that. It'll impact repeat visits if they even decide to come back. So let's start with an example to help frame the conversation around this. This example was captured by webpagetest.org, which is a fantastic tool for testing website performance. This is a visual website comparison of the same website, but only one that's been optimized. They both have identical content and resources, so let's take a look at the visual impact performance optimizations can have on page load. First on the left is the unoptimized video. Okay, so what do we see there? There's a blank white screen until all of the content finally popped in. That was less than 5 seconds, but toward the end, I still felt uncomfortable waiting for that. It felt really unnatural. That's because when we do things in the physical world, we always get an immediate response. You pick up an object, you can immediately feel the weight of it in your hand. You touch something, you can immediately tell its hardness or what temperature it is. But that's not the case with the internet. Excuse me. Second, the video on the right is of the optimized website. It's a little faster here, about a second faster overall, but still there's a very important distinction from the last example. Here in the optimized version, the content appears faster and the site is more visually complete earlier. This is called the speed index, which is a measure of how critical content is visually complete while the page finishes loading. We'll talk about this more later, so keep that on your radar. Now let's look at the play-by-play of the previous comparison videos. This is broken down into half-second increments as the page loads, and it makes the difference between the two examples much more clear. The optimized site displays content as early as 1 second instead of making the user wait almost 5 seconds for any feedback that the page is loading. Also notice in the optimized example, the sidebar is not loaded until last. That's okay because it's not a critical element of the page. The user is probably not dying to see your page's sidebar, so why bother prioritize loading it? Instead, the header in the article prioritized. The header is small, but even by loading a small but critical part of the website, it informs the user that the page is loading quickly. So the critical path is the content needed for a user's current action on the site. That content should always have the highest priority and be loaded as quickly as possible. In the optimized example, the article was prioritized and not the sidebar. The user wants to read the article. They click to read your content, not to see your sidebar. So now let's switch it up and take a look at some data gathered by the httparchive.org. These two graphs show recent trends of website page weight and composition of the top 100 websites on the internet, according to Alexa's list. The first graph on the left shows how the average page weight has increased over the past 5 years. Also, this shows a relationship with the increase in image size over the same amount of time. Images are one of the most commonly forgotten resources to optimize, even though they are comparably easy to optimize. The second graph on the right shows how different resource types make up the contents of these websites in the past year. Images take up the largest slice of 68% of total page weight, and coming in second are scripts with a hefty 22%. Here's another graph of engagement related to wait time. In early June of this year, the engineers at the Financial Times website published an article about an experiment they ran to see how page load times impacted return on investment. They purposely imposed increases of 1 to 5 seconds of load time on their users to test the impact on their browsing sessions. This shows a unified look across all of those weights at the engagement these users had with the website in pages per session. There's a drop in engagement for users visiting more than 2 pages. That's abandonment. That's less ads seen per user, less subscriptions per user, and potentially less return visits per user. Straight up, waiting leads to abandonment. To help quantify this, let's look at some critical limits in a user's experience on a website as defined by the Nielsen-Norman group. At each of these limits, a user's experiences a different feeling. At 1/10 of a second, the user feels the page is reacting instantly and they are directly manipulating the interface. At 1 second, the user's thought process remains uninterrupted and they feel they are navigating the website with ease. However, the closer the wait approaches to 10 seconds, that approaches the threshold of keeping a user's attention on a task. And they're more likely for the user to abandon the task. Anything slower than this needs an alternative way to handle the wait, either with UI indicators like spinners or progress bars, and showing the remaining amount of time is great for the user. You can even send them a notification once the task is complete, and this frees up the user to concentrate on something else besides their frustration. So butter is a silly analogy I like to use for relating performance to users. It's like when you're cooking and you're in the middle of a recipe that needs butter, but you realize that you don't have any butter. Just like performance, you don't want to be stuck in the middle of the recipe without butter when you need it the most. You can also say it's kind of like plumbing because you don't realize it's there until it's missing or broken, except when you make performance improvements, it's a lot more fun to shout butter than it is to shout plumbing. Butter is what a user should feel on a website and not frustration. Their experience should be smooth and seamless. And a user's taps and clicks should feel like natural extensions of their bodies so they get immediate feedback from a device. So all in all, let's make the web fast. Waiting affects the user's ability to accomplish a task, and it leads to user abandonment. That means less subscriptions and less ad views, less engagement. Ultimately, performance can shape a user's perspective of a website or even a brand as a whole. When a user thinks of a website or brand, I would want to be remembered as being fast. All right, so now that we have an overview of website performance and load time, let's talk shop. First up, how to optimize images to improve performance on websites. Like we saw in the graphs before, images are commonly the largest slice of the pie when it comes to resources on a web page. That means they can hold the most opportunity for improvement in performance. But before we talk about that, we need to discuss the differences between types of images. There are two big players in the image arena these days, bitmap and vector images. Both are great for different purposes, so you'll need to learn when to use each. Bitmap images have been around for the longest and are most familiar. They're the well-known file formats like JPEG, PNG, and GIF. Vector images are newer to the scene, but they're fantastic for images on the web. The most common format for vectors is SVG, and it's been a web standard since 2001, so they're very well supported. Now let's look at the difference between the two. On the right, we have a bitmap image representation of Pac-Man. The grid is 18 by 18, where each square represents a single pixel. So there's a total of 324 pixels in the image. Each square must save the image data of that single pixel. So for larger and larger images, you need to save more and more pixels. That means bigger files. Also, if you enlarge this image, you don't get new pixels for free. Imagine if there were 2 pixel margins between each pixel here, you'd have to fill in the empty spaces to make the image look seamless again. So the end result looks jagged and aliased instead of smooth and round. With SVG, you don't have to worry about either of these drawbacks. SVG files are just XML-like text files. And if you're wondering what that means, think of HTML. They're similar to HTML tags, but instead of content, it's for shapes. And these tags instruct the browser how to draw shapes, paths, colors, and gradients, etc. This means the browser can just increase the inputs into those instructions to enlarge an image without any quality loss. It's all just math. So what about optimizing these different kinds of images? Image optimization works on both bitmap and vector images. Unfortunately, to properly optimize images for websites, you need to use lossy compression. Lossy compression reduces quality of images by removing image data. That means each time you optimize an image, it will decrease in quality. But this can have a dramatic decrease in the file size of images, so it's necessary to find a quality file size balance. So let's see what options we have for compressing images now. This is a purposefully over-optimized JPEG image. Its dimensions were reduced by half, and it was exported at 10% quality of the original. Now, it doesn't look terrible, but it's pretty bad. You can understand the image, though. It still has trees, it still has coconuts. But we probably don't want to use this on image full screen, although I am, just for example. On a website, probably a bad idea. So what's the deal with the image anyway, and why does it look so bad? Well, here's a side-by-side comparison of the optimized image next to its original. Now, obviously, by looking at this, you can tell I over-optimized it, and it shows in the poor quality of the resulting image. But notice how much of a difference the optimization made in the file size. The optimized image is about 1% the size of the original. But with that very clear lack of image detail, it is still microscopic in size comparatively. You wouldn't want the user to load the original 14 megabytes over a 3G connection, that's for sure. So here's a few tips for getting the best results out of your optimized image. First, always make sure to request full quality source assets from wherever you get your images. That way, if you over-optimize your images, you can always cut a new one. And if you under-optimize, you don't have to suffer the extra quality loss of re-optimizing a previously optimized image. Second, you want to determine the actual size of the image on the page where you'll be using it. You don't need to ship a giant image for a small space. Then after you've done that, you want to resize or crop away any unnecessary image size to reduce the amount of pixels in that image. And last, always aggressively optimize images. There's no silver bullet quality level here because all images are different. They'll all optimize differently. But I like to start at about 60% and work my way down until I can't stand the quality loss anymore. Most of the time, your users are not going to be putting your images under a microscope anyway, so sometimes it's kind of more than you need. Excuse me, less than you need. Also, if you'd like to automate this process, TinyPNG and TinyJPEG are essentially the same tool that work great on both different kinds of images. Also, the CLI utilities below can be used in scripts and deployments and such, and the Tiny websites have APIs for developers as well. Now let's look at vector images. Vector images are quite different from bitmap images. Like I mentioned before, they're scalable at any size and don't suffer from quality loss from scaling. Optimizing them can be tricky because of the many different possible optimizations available. I like to use SVG OMG, which has a nice interface for showing how the different optimizations will affect the end result of my image. SVG also compresses better than bitmap because they're just text files and can take advantage of gzip compression. If we look at the same image side by side in an SVG versus a bitmap format, we can tell the differences in their use cases. SVG images are great for geometric shapes and displaying text, while bitmap images are not suited for this. The lines are much more blurry in the bitmap image, and the gradients are much less smooth than that of the SVG image. However, it would be surely impossible to recreate the SVG of the palm tree photo we saw earlier. That's a photograph. It doesn't really suit very well for the SVG format. So when choosing a format, consider if the image is photography or not to help determine what type of image to use. The ultimate goal is to reduce the image weight of your web pages by as much as possible. This amount will depend on the amount of images in your site, so fill in whatever number makes sense for you here. One thing to remember is the easiest way to reduce image weight is by removing the image entirely. An image cannot increase load time if it isn't there. Really consider if the images are necessary and always optimize them as much as possible. All right, next up, let's talk about third-party resources and how they impact website performance. Most third-party resources come with some JavaScript snippet that you insert into your website. They enhance your website, adding features like analytics, ads, support, notifications, and share buttons. And these are great, but they don't always require a lot of effort to implement. But unfortunately, they can introduce a lot of performance issues. The biggest drawback to adding third-party content to your website is the lack of control over this content. When you put the resource on the page, you agree to ship anything that the vendor chooses to the user. That means if your website has 3 images on it, and the third-party widget has 11, the user will be forced to download all 14 images. Now, hopefully this is a contrived example, but images are not the only concern here. Certain scripts can block the page from rendering, forcing the browser to wait until the script is finished downloading, until it can continue rendering the rest of the page. Other scripts are not optimized. It could be much larger than they need to be, and it's not always possible to fix these upstream issues because you don't have access to the scripts. Here's an example of a popular newspaper website, the New York Times. Just by looking at the top part of the screenshot, you can tell there's plenty of third-party content on the page. I see 2 ads and some share buttons, and that's just above the fold. Now, diving under the hood, we see the network tab of the Chrome developer tools open here. The big green arrow is where the DOM content loaded is fired, which means the HTML is finished loading without waiting for any other resources to finish themselves. That HTML includes the critical article content, which loads in under 1 second. And that's pretty good. That has to feel nearly instant for the user. The big red arrow is when the document load event is fired. This means the page and all of its resources have finished loading. That's over 5 seconds from where the content first loaded for the user. And that's not terrible, but it's important to remember that there are competing interests here. Here's the same page, but taking a screenshot at the green arrow. Notice we don't see any of the third-party content compared to the fully loaded page. And we shouldn't see that content because it's not critical to the user. You get to decide what the critical content is for your user, but you want to make sure it matches the user's expectations. You don't want to stop the page from appearing to load by blocking the scripts, but you also might need to collect analytics and stuff like that on page load. This goes for all scripts, including web font loading scripts and social network scripts. And fortunately, a lot of companies like Add This take performance very seriously and provide non-blocking ways to load their scripts. So, when should we add third-party content or remove it? Performance budgets are a great way to help balance user needs with business needs when it comes to external scripts. For example, if you have a goal of your page being visually complete within 2 seconds, you might have to sacrifice some third-party features to accomplish this. Instead of loading ads in the critical area of the page, you have to display them after the user scrolls. That might mean adjusting more than just scripts, like something like design might need to be taken into account as well. But that way we can delay the necessity of a script being loaded and instead load it later after the initial page is loaded. Third-party scripts can also change without your knowledge, so keep that in mind when monitoring for performance changes. A good way to start is by making a performance budget around the speed index metric I mentioned earlier. An ideal target for cable connections would be 1,000 speed index and 3,000 speed index for 3G connection. These aren't easy targets, so use what makes sense, but you've got to be ambitious about this stuff. A lot of third-party vendors will provide instructions for asynchronously loading their scripts, including Add This, but if they don't, or you just want a little bit more control over how the scripts load, you can use a load.js function by the filament group. This function always loads scripts in a non-blocking way and allows you to conditionally load scripts however you please. Also, make sure to test your pages thoroughly as your users would use them. A lot of users are still without true broadband, so make sure to test in slow connections to see how a slow loading script could impact your website. Also, make sure your page is not dependent on third-party scripts because users will inevitably block third-party content with ad blockers and such like that. Moral of the story is, you never know what a vendor will ship in their scripts that you add to your website. You want to balance user needs with business needs and load only critical content first. So far we've only looked at 2 ways to decrease page weight and load time by reducing image size and third-party content. Now let's see how caching resources and content delivery networks can benefit the user. And I'm going to refer to content delivery networks as CDNs from here on out, since the non-acronym is a mouthful. Let's start with caching. Every time you visit a web page, your browser needs to download resources to display the content. It's nothing new here. We've been talking about that the whole time. But chances are within the time you're browsing a site, the resources won't change while you're on it. And if they do change, they might just be piecemeal changes. It'd be rare to be browsing a website and suddenly the page you see is a brand new redesign of the site with completely different assets. So these resources you've downloaded probably won't be stale anytime soon. The browser keeps them in a cache to be used again. Instead of needing to download the same resource twice, we can use the cache version and save a lot of loading time. Here's an example of how a browser handles a request to the same page on a repeat view. The first time we visit in the top half, the browser sends a request to the server to retrieve the resources on the page. That dotted line in the middle represents the internet, or where we need to reach out to get the content from a server. In the repeat visit on the bottom, we don't need to request those resources again. We just browse to the same website, so the resources probably haven't changed since our last page view. Instead of getting the assets from the server again, we just use those assets that are stored in our browser's cache. This can greatly reduce the load times for subsequent views on a web page. Now, setting up caching on a website is more technical than the previous few tips we've discussed. But there's a few simple rules to remember when caching. First, only cache static content. If you were to cache a user's dashboard page, which is completely dynamic, any other user that browses to that URL will see a different user's dashboard, not their own, because that's what's cached. So it's a good idea to limit caching resources to those that you know will remain static for a long period of time. Resources like images, video, and text are great candidates to be cached. Second, this is the technical part, you'll need to set cache control max age headers on the responses your server sends to browsers. I've highlighted this in the image to the right from the Chrome Developer Tools Network tab. The max age is set to over 3 million seconds, which is the number of seconds in a year. So assuming the files remain unchanged or the cache hasn't been cleared in your browser, a user could browse this website for the next year without needing to request new resources from the server. Notice also the highlighted status code of 304 not modified. That means we already have the resource requested in our cache, and we don't need to download it again. Third, you want to make sure you cache bust your assets with version hashes. This way, if you do need to ship an updated file to a user for a bug fix or style tweak or whatever, the users are guaranteed to download the fresh updates from the server since the file name is different. This is highlighted in the top of the image, and you can see the difference in hash there. The best practice is to automate all of this. There's grunt and gulp workflows out there for this, and web frameworks like Rails and Django also have techniques for caching and cache busting assets. Basically, just cache everything. All right, maybe not everything. Like I said, dynamic content is not suitable for caching, but there's simply no excuse to not cache every static resource on your page. Even if your initial page load is abysmal, caching can save you from user abandonment since repeat page views will be speedy. Now let's talk about CDNs. So far, we've been talking mostly about size and time with respect to website performance. However, distance is a big factor in the time it takes for a server to deliver a response to a browser. CDNs reduce the distance between your website's resources and your users by distributing those resources across the globe. Instead of a user in Asia needing to request an asset from a data center in Virginia, they can go to a closer CDN server in Asia for the same resource. This is also more technically involved to set up, but there are many CDN providers that have step-by-step instructions for how to configure them with your website today. To help me visualize this personally, I like to think of a pond with a bunch of lily pads in it. If there's a food or a treat we want to get on the lily pads, we need to hop across them to get to it. In this case, we only want to jump to the paths that are closer to us to avoid waiting extra time for our feast. Similarly to websites, we're going to deliver that resource as fast as possible to the user, which means using the closest server that has that asset. And CDNs make up the heavy lifting of spreading these resources across the world a breeze. For example, Amazon Web Services CloudFront has servers in the United States, in Europe, Asia, Australia, and South America, and it's never been easier to distribute these across the world to speed up a user's experience. To get the max benefit of a CDN, you want to use both caching and CDN in conjunction, so the initial request is speedy, as well as all subsequent requests. And I believe AWS offers about 50 gigabytes of free data, or 2 million requests, whichever you hit first, before you have to pay for any CDN usage. Key takeaway here is just like caching everything possible, you should always use a CDN where possible. They're relatively cheap and even free like we just saw, and the performance benefits for users across the world can be huge. All right, so we've covered 4 distinct ways to decrease load times and page weight on websites. But what if you try all of these things and you still can't seem to meet your performance budget? You're just gonna have to get a little bit creative here. Perceived performance is how quickly a feature appears to perform its task. This can be accomplished in different ways, so let's look at a few approaches. It's important to know that just because you're aware as a developer of a heavy resource or a long-running task doesn't mean the user needs to feel it. Perceived performance is all about hiding wait time for a user instead of making them wait for the task to complete. Especially when the task falls in that 10-second or greater bucket that we saw earlier in the talk, the user can still get the impression of a smooth interaction if the wait is managed appropriately. One example is using low-quality image placeholders. This requires a bit of orchestration on the front end and the back end. You need to prepare separate low-quality images of your image in order to first serve these to the user. Although the initial image is very poor quality, it still captures the essence of the image. You still get the green and orange colors and maybe some abstract trees in there too. This can greatly reduce the page load while still giving the appearance of the page being popular with content. In the images in this slide, for example, imagine we had a gallery page with 24 thumbnails on it. If they were all high-quality thumbnails, that'd be 24 images times the 68 kilobytes, which is over 1.6 megabytes of image thumbnails just for initial page load. Even half of that weight is way too much. Instead, we can use low-quality images, which would only use about 110 kilobytes of initial page weight for the same amount of image. That's 93% less image weight. Once the page has been loaded, we use a lazy loading script that kicks off the loading for the replacement high-quality images. You want to use a solid and fast CSS transition to hide the loading of this, so there's no popping in appearance. It's more of a fade. It's also a good idea to provide Node.js fallbacks with no script tags, and this technique is detailed in the lazy sizes library that I like to use in the link below. Here's actually an example of a website that I work on in my day job. This is just-in-time loading. So we have a user registration form. We want to make sure the user considers the strength of their password during registration. Notice the password fields are far down in the form, which means we don't have to immediately load any of the password strength scripts. Good thing too, because the library we use is over 320 kilobytes, and so it's great to be able to delay that heavy resource until later. So instead of loading it immediately, we wait for the user to focus a field in the form. The likelihood of a user focusing one of the password fields first is slim, so while they're filling out the rest of the form, we can load the password library in the background. For this, we use the load.js function I mentioned earlier, and it created a much more seamless experience for the user, not having to wait on the initial page. And finally, if we need to do some long-running task in the background, we want to make sure you acknowledge that to the user. They'll understand that this is a continuing process, and they're able to free their attention for focus elsewhere. This means more productivity for the user and no frustration from staring at a stupid little spinner on the page. All Mac users know how annoying it can be to watch a little rainbow pinwheel spin, spin, spin. So it's a great idea to inform the user of the amount of time it should take. You can even send an email if you know this is going to be a very long-running task. Ultimately, you want to hide the wait if you can't avoid the wait. Your users are going to thank you. And with that, I want to thank everyone else for participating in the webinar. I hope everyone is more equipped with knowledge to improve web performance on their websites. Also, big thanks to AddThis for hosting the webinar, and I'll hand it back over to Justin to start off the Q&A.
Awesome. Thank you so much. Let me share my screen. Yes, as Andrew mentioned, this is the time for the question and answer portion of the presentation. So we're going to bust through as many of these questions as we possibly can. So yes, please Cue them up, please. Michael asked if you could speak to some words regarding tracking down potential bottlenecks in SSL transactions.
Yeah, absolutely. So SSL definitely increases the time it takes to make a connection between your server and the browser because there's additional work that has to be done to verify the encryption connection, things like that. Really, it's not generally a big concern because this usually completes pretty quickly. But if you need to track down bottlenecks, Web Page Test is a fantastic tool. They actually have a nice network waterfall showing all the assets in your page and how long each part of the request took. So they color code like the DNS lookup, the SSL handshake, the actual content loading itself. And so that's a great place to start.
And as we mentioned at the top of the webinar, we will be sharing this around both the slides and a video of the presentation after the webinar is over by email. So definitely look out for that. So all of the resources that Andrew mentioned will both be linked from the recap, but also will be linked in the slides, and you'll be able to rewatch this at your leisure afterwards. Kevin wants to know, talk to me about image formats. What do you think about WebBP? Is that worth it?
I'm not familiar with WebBP. I've heard of WebM. I think WebP as well. They're fantastic. They're relatively new though, so browser support might be limited, especially if you need to support older browsers like the Internet Explorer family. But they are definitely a future. They offer a lot more compression than JPEGs and GIFs and PNGs can offer. Awesome. Looking forward to more adoption in the future of those.
Next question. Can you tell us a little bit about the difference between SVG and SVGZ? This is coming from Frank.
I do not know much about SVGZ, to be honest. I really only use SVG images on a day-to-day basis, and I would love to know more about SVGZ as well.
Oh, any other thoughts in terms of like SVG 1.1 or SVG Tiny 1.2?
Again, I'm not super familiar with the differences in the versions of formats. I do know that SVG animations are kind of going the way of the dodo, since we can use SVG or CSS animations instead.
Awesome. Ramon wants to know, what is the most commonly used CDN? Would it help to combine multiple CDNs, or would that have a negative impact?
Well, I'm not sure the most commonly used is. I know Akamai is a great one. CloudFront's good too, and there's also Max CDN out there. There's probably statistics somewhere about what the most popular is. I personally prefer CloudFront because it's easy for me to set up, and there's a great free tier. Combining multiple CDNs is probably not going to benefit you too much. You just want to make sure that wherever regions you're specific in targeting, that the CDN you choose does provide servers in that region.
Awesome. Next up, Frank wants to know, can you talk a little bit about performance in WordPress? Do you have any thoughts there? It sounds like he has a lot of clients that are using it.
Yeah, WordPress. I love WordPress. We used to build a lot of WordPress sites, and it always seems like I bend WordPress to my will whenever I need to do some client custom requests. But there's plenty of opportunity you can do with lazy loading on WordPress, for example. You're going to have to get into the PHP side of things in WordPress. Chances are good that if you just buy a theme off a theme forest or something like that, you're not going to have performance out of the box. And so you're going to need to get familiar with the internals of WordPress and how scripts load there to do anything with it.
Awesome. Thank you so much. Just looking through any questions left. You can all see these, which is fun. Do you have any examples of fast sites with all the mentioned things? Someone made styles, maybe.
Well, New York Times is a great example of loading third-party content in a non-critical way. I know Google has started mobile pages and Facebook has instant articles. My preference would be that that's more of a web standard, because I think those are a reaction to poor performing websites instead of developers taking responsibility to make them quick. But if you want to read more about why the decisions they made for how to keep performance so fast, those are two great resources, AMP and instant articles.
Fantastic. And then last question. It sounds like Frank has a lot of colleagues that use Google PageSpeed Insights as kind of the authoritative source, and it sounds like there may have been problems with that in the past. Yeah. Not being authoritative, do you have thoughts on Google PageSpeed Insights and
So I love Google Page Speed Insights, but I tend to disagree with some of their I guess some of the feedback they give you, because some of it doesn't apply to all websites, and it's a great reminder for me that these are just tools and they are providing suggestions for you. And just because you don't have 99.999 on all of the page speed insight scores does not mean your website is malperformant. And so really make sure you put that in perspective for how your users are using the site, because some of their feedback just might not apply to your website.
Awesome. Thank you so much, Andrew. And thank you for your insight and for your knowledge. We really appreciate it. Thank you to all of us. Thank you to everyone for joining us. We're very grateful for your time, and hopefully that you have found this helpful and useful. You'll be getting a email shortly after this webinar asking to fill out a survey. We'd very much appreciate it if you do that. Your thoughts, feedback, letting us know if you found what Andrew said today, if you found it helpful. And for the first time, we're actually going to announce our next webinar today. So no one's seen this yet, so definitely you can go right now and get your seat reserved. Our next webinar is going to be how to grow your email marketing list. And this is with our partners over at Aweber. So I know this is a little bit of a long URL, but if you go to go.addthis.com/list building webinar, go there right now. It's all up there. We'd love to have you for our next in the series. I know this one is a little bit more developer focused. Hopefully there's a few marketers in there. Maybe some of you developers are interested in figuring out how you can build an email list. It won't be specific to Aweber, more just kind of broad stroke tactics about the importance of building an email list, and then specifically how you can get started doing that today. So, but again, thank you to Andrew for your knowledge. Thank you to all of you for coming. Definitely look out for both the survey email, but then also the recaps, both of the video slides and the actual recap article in your email. Thanks again, and have a fantastic day.